Welcome to the Texas Panhandle Builders Association TPBA Builder Talk podcast, where we'll bring you expert advice from the heart of Amarillo building community. Whether you're a seasoned professional or just starting in the trade, our goal is to keep you informed on the ever-evolving building codes, share best practices, and help you excel in your craft. From innovative design ideas to smart material selections and everything in between, we're here to support you in every aspect of home building. Each episode, we'll dive into the topics that matter most to builders, contractors, and industry professionals, ensuring that you stay ahead of the curve in this rapidly changing landscape. Our discussions are shaped by the experiences and knowledges of our hosts and guests, providing you with valuable perspectives that you can apply directly to your work. The views and the opinions expressed are those of the host and the guest and may not always reflect the most up-to-date or accurate information. Let's build something great together, one conversation at a time. Welcome back to the TPBA Builder Talk podcast. It's been a little while since we've had a podcast recording.
Happy New Year.
Happy New Year.
Happy New
Merry
Year.
Christmas. I think
Hope everybody has a great year.
Thanksgiving, I don't know, but it's been a bit, and so we're excited to be back. But before we get on today's topic, we want to thank our podcast sponsor, which is Huber Engineered Woods. So Huber's been around for a long time, since 1883. They make a lot of building products that support us as local builders that are popular here in even Amarillo. So we've got the Zip system and their sheathing, their Zip R, Advantech subfloor, their tapes and sealants that make one cohesive system that take care of structural, air, water, and thermal. And we're really proud to have Huber as a sponsor. So thanks, Huber. Anyways, on to the show today. We're talking about roof framing. You guys ready for this?
Absolutely.
I thought this was the foundation day. Oh man, I'm not ready.
It's a new year, starting a new house.
Oh, really? We're to the roof already?
We're to the roof.
Okay,
We're to the
we're
roof.
talking about the roof.
Hopefully, it's not
Roof
the
framing.
slowest house ever being built as we do it verbally. But
Yeah, true.
anyways, we're gonna talk about.
I think it's right on schedule.
It might be, you know,
The schedules are slow.
as long as we're having change orders, we'll be on
Yeah,
time.
I think
Yeah.
we're on time. What's our moving date?
Well, let's discuss the hand cut side of things first, right? So we're going to go over the names, what we refer to them as, the parts and pieces that hold this roof system together, and then we'll transition into Joel, what you're a lot more familiar with than we are, is truss and how the truss process works as far as putting into plans, getting them built, making sure they're meeting specs and they're engineered, and then even into the installation of them if you're good with that. Anyway, so let's kind of start. I think we left off. We've talked a lot about wall framing. I mean, we made 2 really long episodes about that. There was a lot to discuss.
So, hey, Joel Rafton for the Duration Home.
Yeah,
Ben Hardesty, Southwest Sales.
and Jordan Dugan with Caprock Design Build. back at it.
That's us.
Yep.
Missing on one of our counterparts today.
Yep. He's working for a living.
I don't know.
So-
What's the starting point on hand cut roofs? Okay.
Well,
so
you got the double top plate, and then from there, that's the roof. And it seems like a lot of times in framing, not everybody can hand cut a roof or do a roof.
it's true.
So you got a wall crew, and the double top plate's done. Everything's string lined, and everything is supported, and then they get the next guy in, the guy that can cut the roof.
It's very true.
You know, I know that now it's a calculator. That the little blue book still
That's right.
comes with the little squangle. There's a little blue book. Everybody knows it as the blue book.
Yep.
Yep.
And it's all the span charts and the commons and the hips, about everything. You just kind of follow the book. But the next guy up is the guy that knows roofs.
That's right.
You know, and he's not necessarily the guy that's doing the walls.
So around here, we've at this point the walls are squared, they're true, they're plumb, they're level, and they're being held in place with our ceiling joists. That's kind of what's ultimately tying together. I mean, we've got temporary bracing still, but those ceiling joists are, setting those spans at a specific distance and being installed so that those walls aren't going in and out before we ever stack our rafters. And so let's break down the parts before we assemble them.
In a perfect world, doing what you just said, putting the joists in and squaring everything up, then you can cut rafters on the ground, throw them up, and every single one will fit.
Yeah.
Yes.
And that's why you want to take the time to do the good job on your ceiling joists
Mhm.
and squaring everything up. Otherwise, you're throwing a rafter up to the guy and he throws it right back at you. I need I need another extra half inch or
Yeah.
another inch. And you're like,
Yeah.
because you didn't do the work up front to square everything up,
Very true.
set your ceiling joist, make that perfect box a box, then it's a good day.
Mhm.
So
And-
you're
and-
right. That needs to be done.
And it is very calculable.
Oh, for
you
sure.
Use a book. It's and if you make those measurements and you cut it what they're supposed to be,
It's
it
like
will,
a glove.
It will fit like a puzzle piece.
It's so weird.
Imagine that math. It works sometimes,
Yeah,
I guess.
and it really does work.
But that is in some manners that is considering it as a perfect world. Now there's plenty of houses that get framed in there, you know, they're cut by the book and they work, but there's times that there's exceptions and, you know, yeah, you may throw a piece down and cut a new one and maybe it's just one or two, but for the most part, I think a lot of the framers around here are, you know, they're not pulling a tape from, you know, their ridge board back down to get their rafter cut
no
length
way.
and measuring each one. They're cutting them all on the ground and using
Yeah.
them.
From what I could tell, they do a good job.
Yeah.
You know, the hand cut world for me had gone away a long time ago.
Yeah.
So to see a lot of skilled guys doing hand cut, it's pretty cool.
Yeah, there's craftiness to it. It's kind of, I don't know,
Forethought, a lot of
by
forethought.
some builders kind of romanticized as the, you know, I don't know, the cool way of framing. I don't know. It's got its craftsmanship involved.
Yeah,
into
it does. It's hand cut.
It's
With your hand in your brain in each piece. It's a handcrafted deal.
But let's talk about the pieces. So we've got ceiling joists. Those are the things that are holding up the drywall on the ceiling that run from wall to wall, bottom level, bottom of the triangle, if you will.
Mhm.
On top of those, we've got our rafters that are running at an angle that make up the sides of the triangle. Then those are running into commonly what is around here is the ridge board and not the ridge beam.
And I guess if you're talking about rafters, you kind of want to talk about pitch.
Yes.
You know, the roof, the steeper it looks, the bigger the number.
Do you have
Yeah.
to change the width of the board if you go with the or like does your pitch change? You have to go from 2x6 to a 2x8 or anything?
Not necessarily. You're changing. All you're changing is the angle cuts on those boards.
The boards do get longer,
they
and
do
then it goes directly to the span chart.
Mhm.
So yes and no.
Mhm.
You know, depends on the rise and run how far you're going. But
So you've got, you know, the way those are referred to is they're 112, you know, 612, 1212, but it's the rise over run. So it's I don't know, there's a better way of explaining that, but it's
for every lineal foot, it goes up whatever the pitch number
right
is.
every 12 inches. So if it's a 2 and 12, you're going up 2 inches for every 12 inches across. If it's a 12 and 12, you're going up 12
45
inches
degrees.
Mm-hmm.
for every 12 inches across. So rise over run.
And each pitch has a degree number.
Yeah, absolutely.
And so that's how you start the hand cut process.
Absolutely. Those rafters are, like I said, tied into a ridge board or ridge beam. But here it's a ridge board, which is usually a 2x member, you know, whether it's a 2x6 or a 2x12 or whatever it may be. And then those are laying on top of those rafters are laying beside your ceiling joist on top of the top plate.
So getting back to your ridge board or your ridge beam,
Mhm.
you're using a 1.5 inch member at the top,
Mhm.
and you're running your rafters in. How do you see the connection? Is it nailed from one side, then toe nailed into the other side? What do you guys see for a connection at the top? Is there some hardware? Is it blocking? Is it pressure blocked? What do you like to see on the hand cut where the actual rafters hit the
They're
2x?
they're nailed, so they're not often pressure blocked in between or hangers. And if you think of it as if they're being held at the ends, which they should be, so that the walls can't be pushed out, the rafters can't be pushed out, and you're on an angle, then the down pressure that's experienced on that ridge board, the only thing that really even needs to be held there is side to side motion. It can't drop down anymore. So you're not needing a pressure block to hold that board from dropping down or a hanger to keep that board from dropping down. You're just needing to fasten that for its left.
So it's more of a fastening issue. So you're counting on the nail guy with the nail gun getting him from one side of the ridge straight in,
Mhm.
and then from the other side, you're hoping it doesn't go too much of an angle to blow the rafter out. But then you have the collar tie that's helping it anyway.
You are.
So it's just the collar tie for sure holds it in place,
Mhm.
and the sheeting holds it in place. But
Yeah.
I just wondering what kind of connections you see there at the top.
That's
Just nailed,
Just-
and then
just
down at the
nailed.
bottom, nailed.
And then you've got, like you said, your collar ties, which visually, if you think about it, it's making a smaller triangle at the top of that roof system.
Mhm.
So it's again kind of holding those rafters to that ridge board, and then and keeping any deflection from coming in those rafters. And then lower on that, you're going to have your purlin and your supports. Which I think right now are every 10 foot. And it seems like, we don't have our counterpart here with us that usually inspects this, but it seems like they're maybe moving that to 8 foot.
So a purlin is just an additional support for the run of that rafter, is what you're saying?
Exactly.
Because the rafter is running from the outside wall way up in the air all by itself,
Mm-hmm.
sitting there just kind of hanging in suspended air. And then you're trying to beef it up, but then halfway down the span, you want to beef it up even more. So you're running a kicker or a purlin
Mm-hmm.
down to the ceiling joist system.
That's right.
Okay.
So if you think about it as,
When you say every 10 feet, that's not every rafter, then that's every so many rafters,
well,
unless it's a knee wall system.
it's actually would be all those rafters. So if you've got a 30-foot rafter, at two different places, you would need to have purlins to support one 10-foot section and another 10-foot section from ridge board to
the
top
outside wall.
plate. Yeah. And
So you're doing the next rafter and the next rafter and the next rafter. Each rafter gets that same treatment,
if they're over a certain,
Sure.
if they're over 10 foot,
unless you're going to do a knee wall.
unless you're going to do a knee wall. And if
Okay.
you think about it in terms of like a ceiling joist, ceiling joists have to be sized to span a certain distance too.
Right.
So depending on what the size of your rafters are, should determine where those purlins are and if needed. If you've got, it doesn't happen around here, but if you had 2x12 rafters, those purlins are going to be a lot further apart.
There'd be a lot
Yeah.
fewer of them.
But you're going to have a more expensive roof system because you're paying for more wood.
Sure.
So this is a way to allow for common 2x6 rafters to be used to span, up to 32 feet, 34 feet's kind of, I think that's the longest you typically buy at the lumber store, 32, 34, one of the two. And, you've got two purlins that support that, and that makes that span possible.
And the purlins are supposed to be down to a supported bearing wall of some sort. You don't just stick them where you want them.
They're supposed to be to a load path.
Right, down to the foundation.
Down to the foundation. So it doesn't necessarily have to come on a bearing wall, but you would need a supporting member that maybe straddles the bearing wall. And so
or
that
close to thereof.
that in turn, that kicker, that support member would go to a beam or, LVL or what do we refer to it as L?
Well, you need to make a strong back of some sort. So if you're going to span a bunch
That's
of joists and you're 4 feet off of a continuing wall, that will help you get closer to that wall.
Yeah.
So it's interesting because and you said at the very beginning, it's an art form.
Yeah.
It's not real. I mean, it is science for sure, but it's massaged as you go.
Mm-hmm.
And if you are looking at a finished product and you go down, over, missed it, but we have a strong back, yeah, that'll work.
Mm-hmm.
So it's a little subjective in the concept of efficient of a rule of thumb. I mean, it's a rule of thumb, is what it is. It's not drawn like black and white. It's not black and white. It's kind of black and white.
It's a very site built thing.
Yeah.
Even in the terms of most residential plans don't even call out for the specifics in the roof framing. Now there are some. I've built houses that have the roof plan details called out for every single cut, angle, and everything on it. But in general, it's here's the size of your roof, here's the roof pitch, here's where
the valley is,
here's the elevation, and here get after it.
And that's why I say it's such an art form. And these guys that do this hand cut stuff, they're super skilled.
Mm-hmm.
It's cool to watch them.
It is, and it usually happens quick.
Yeah. I mean, every time I drive by one, I slow down and go, Yep, that guy is cool. He's got it.
On the bottom end of that, so where that rafter is dropping down onto that top plate, there's often what's referred to as a bird's mouth cut, which is another kind of triangle, so that rafter can sit and be seated onto that top plate, kind of pocketed into that top plate, which also helps that vertical movement stop.
Mhm.
Right? It gives it a more of a resting point than just having a little skinny piece of the top plate wood and the rafter joining at that corner on corner. It's got a full bearing of 1.5 inches at that point.
And that gets attached to the double top plate.
It does.
You know, there's a couple different ways they can toenail it. They can use some hardware, some Simpsons hardware.
Mhm.
You can block it, so it's attached.
Structural screws, like
Those are cool.
yeah. Those I think are relatively new, and when they came out,
Yeah.
I found a million uses for them.
Yeah, that tool that they have to put them into. That's
Mhm.
we're talking about. Simpson came out with these orange screws. Are they 3 or 4 inches?
The ones I typically get they're 8 inches long.
Oh yeah, right.
And they're threaded all the way up to the head, so there's
Yeah.
no
In
bear
fact,
shank.
you don't have to use hurricane clips. You can use those screws. They
Mhm.
take the place of hurricane clips. How many thumbs have you smashed trying to put hurricane clips on over the years?
Quite a few. I've had not using positive place nailers. I've had a 16 penny nail go through my thumb before, being in a hurry and not using the
Yeah.
right tool. And
But
Yeah.
the screws you can put on, well, probably not 10-foot ceiling, but for the most part, you can stand on the floor and put them in.
they make extensions for your impact
Yeah.
drivers, so you can do like
Yeah.
a 10-foot.
Yeah, those
Super
are pretty,
cool.
Those are pretty cool. Yeah, that was a good one.
So those just go up through the bottom of the
Top plate into your
the
rafter.
Well, yeah, kind of at
and
an
the-
angle,
hmm
you know.
Yeah.
Yeah, and then you just goes to the bottom of the rafter and it just sucks it down, and that's
Mhm.
it.
hmm
I don't want to say they're a must.
Uh,
You know,
They're-
talk about positive connection.
it definitely is one of those items that is worth what you spend on it and adds a significant amount of integrity to the house.
Yeah, it totally does.
Um,
So if you get that dead on, then the blocking doesn't become such an issue.
you're talking about the blocking between rafters.
Yes.
So it's not commonly seen around here. We were talking about this earlier. A lot of traditional framing all over the country has a blocking member between those two rafters, keeps those rafters from going side to side.
And if it's an open soffit, they're vented.
Now,
If you do a venting, the bird blocks, the birds can't sneak in
Mhm.
there. There's a lot of reasons for them, but I think part of it is some seismic reasons. That's
Yes.
maybe why you don't see them so much around here.
well, and
or-
we have so many closed soffits. So if we had
Yeah, everything's closed soffits.
what I was getting to is we don't have a lot of open rafter ends, rafter tails, and sometimes they're decorative, and you see them on older homes. You don't see them on new homes so much, and when you do, a lot of times they're it's a separate attachment. And
Like a patio or something like that.
yeah, it's they'll make them out of they make them out of PVC, they make them out of wood, but you basically buy this decorative rafter tail
Mhm.
resembling piece and attach it to the side of the house. To
But
make it look
a
like-
closed soffit has always been an upgrade.
yeah.
It's been $1 upgrade. I mean, the standard house is
Right.
an open soffit, bird blocks.
Mhm.
That's what you get, and with the lumber is being as not as good as it once was, it doesn't look so great.
Mhm.
You know, you got a lot of wane on the wood. You look up but that's the standard house. And if you want a closed soffit, you're writing a check.
Yeah.
But around here, it's just the opposite.
It's the opposite.
It's all closed soffits.
And so we're usually putting a 2x6
Probably
on,
because of the brick pocket. The more I think about it, everything around here is brick.
yeah.
And
Well, you have to bring a trim down to that brick if you've got an open rafter
which would
system.
look goofy.
You see it on some of like the houses built in the 50s.
Yeah.
Um,
I'm saying from the modern house that we're doing now, you'd have to close the soffit in with the brick pocket and everything's in brick, so it makes perfect sense
mhm.
to have closed soffits.
Mhm.
And if you're doing a closed soffits, then maybe you don't need that block of wood in there, because in your case, you put a 2x6 fascia,
Mhm.
sub fascia on that holds the rafter tails together.
Correct.
And then do you put the screws on every house too? The truss screws, or that's your new standard?
It's not a set in stone standard. It is something I very much prefer to do.
Yeah, it's pretty cool.
And depending on the construction of the house and the design of it, what's going on with it, we'll either require them or we won't.
I mean, the framers don't care one way or the other if they're just saying hurricane clips.
Yeah.
So, I mean, so when we're talking hurricane clips and all these attachments, when this rafter sits down on the plate, we don't want uplift. We want it to stay on the plate, more than just the two nails.
Mm-hmm.
So either we're doing these long screws or we're doing what they call hurricane clips, which is a little piece of metal, kind of turn it at a 90, and then you can attach it to the plate and you attach it to the rafter, and then every single rafter gets one.
Mm-hmm. And it's a significant improvement. It's what actually prevents any kind of uplift. Otherwise, you don't have much uplift prevention.
It's just the nails.
Mm-hmm.
When you do the blocks, you have a ton of uplift because
Yes.
you're nailing the blocks to the plate, and every single rafter gets nailed to the block, and you can use hardware on top of that, but that's kind of overkill for this area.
Mm-hmm.
But the hurricane clips and or screws are part of our whole system, whether it's trusses, whether it's hand cut, that's the attachment
Sure.
that we have to do at the outside wall. And then depending on layout and how this turned out, you also attach those rafters to the ceiling joists,
Absolutely.
so that attaches everything
And
pretty darn
those-
tight.
And those, if the layout doesn't work, and this is something we talked about before we started the podcast, is layout options. So, you can do 2-foot centers, you can do 19.2s, you can do 16, you could do 12-inch on your rafters and your ceiling joists. Now, maybe you do, 16-inch centers on your rafters and 19.2s on your ceiling joists, or the opposite.
Right. Then your layout is, and then you're not attaching.
You're having to block those
Then
out.
you block
so
those, so you're not attaching the actual rafter to the ceiling joist. So you have to throw some blocks in there.
That's right. There would be a gap between the rafter and the ceiling joist where it
Right.
lays on the top plate, and you would need to put in a filler wood so that those could all be fastened together.
Right.
So it's common that you see I say that. A lot of times around here, they're doing 2-foot on center, I guess, on a lot of it, but 16 on center on the ceiling joist, 2-foot center on the rafters. Sometimes you'll see 2 foot on the centers of the ceiling joist and 2 foot on the rafters.
There's a lot of considerations on what you do, and you don't mind doing 2-foot centers on your ceiling joist if you only have an 8 or 10-foot room.
Mm-hmm.
But if you're really running across a 20-foot room, you got to think about it.
Yeah, the more of them you have, if they're installed correctly, then the less likelihood of any kind of bow or waviness that you're going to have. But on the contrary to that, if your wood's not straight and your framer's not paying attention to getting that stuff level, the more of them you have, then the more chance you would have of having some waviness in there. Although it would be more, solid, sound, structural. It's just kind of the preference of the builder or the homeowner of what they're going for.
If it spans too much, then you can kind of cut across with a double LVL and split your span.
Mm-hmm.
I kind of did that on a couple of houses. I just had a little triangle that was out in no man's land, and it wasn't going to span. So I just chopped it in half, threw a double LVL there, and just ran the ceiling joist the other way.
And it's always easier to find a straight short board than it is to find a straight long board.
Right.
So,
everything we're talking about, and people are listening and they're trying to close their eyes and imagine it or what they've seen driving down the road. We're talking about an attic space because of all the purlins and everything else. But most houses will have a vaulted great room, so it's a different thing. It's a different cut, but now there's no place for purlins.
The sizes of those rafters would change.
The beam is now a beam.
That's true.
The ridge is not just a inch and a half product. It's either an LVL or double LVL, whatever it takes. So now this triangle has to stand alone. It doesn't get the help of a collar tie. It doesn't get the help of a ceiling joist. So it's a little different beast. Still hand cut, still a cool piece.
It is.
Most great rooms are not flat ceilings anymore.
No, and now we often do in-house design. This is speaking from my experience. In-house design and construction plan, I guess, is kind of a way to term that, not just design. We try to opt for having a separate, even on a vaulted ceiling, we're trying to opt for having a separate plane from the roof. So we may do a vault in a great room, but if the house is an 812, 1012, or 1212, then we'll look at doing a 612, 412, or a 312 on that ceiling so that we can still have that space in the attic and frame it separate from the roof.
Like a scissor vault.
Yeah.
That's what we call those.
Yeah.
Yeah. So it's a vault within a vault.
Yeah. Just to
Because that way the inner vault isn't holding up the snow.
That's
And
right.
the roofing, it's just holding up sheetrock only.
There's from what I've tried to gain knowledge on, there's less condensation risks with that. You have more room for insulation. You have room to run ductwork or electrical.
Yeah.
You've
So
got
it's the way to
access.
go. I mean, old school's true vault, you just don't see them.
You don't, not
Yeah.
very much anymore.
Right. We used to do true vaults with beams 4 foot on center and car decking.
Yep.
What do you do with that? I mean, you had to insulate the top with something. And other than that, they stain the inside and that's all you got, like an A-frame kind of thing. But a scissor vault really is the way to go.
Yeah. And you can have trusses manufactured that way as well. Well, so we've kind of gone over all of the, I guess, the names, whether we made those very clear to you guys or not. We at least mentioned
we made all
them.
those up. Those aren't real names.
Well, you
Where's
got
the
rat
disclaimer?
run. We didn't talk about the rat run, but
Yeah, so rat run, I don't know what the official term for that is, but that's what every frame around here is going to call it. And it's usually a strong back that's placed on top of the ceiling joist just to keep those from having any movement. I don't know, horizontal movement, I guess. It also
Helps you walk on them.
it can help you walk on them. Yeah, because it keeps them from separating when you got an angle weight on them.
Sure.
I don't know.
can you? So you cannot use that as a rest for a purlin coming off of the,
Yeah, you can. Yeah, you can.
You
as
can.
long as it's overlaying on
A
a.
bearing wall.
Yeah, or close thereof.
Yeah. Yeah, that's the you have to be able to trace down your purling kicker support to a load path. So
Okay.
a substantial load path. So now a ceiling joist has a load path to a wall, but if it's a 2x6 ceiling joist that's spanning, I don't know, 14 feet, and you put more weight on it than just the drywall, that's not a sufficient load path anymore. However, you go perpendicular with that and put a strong back on it, and now it's spanning 20 of those.
Yep.
You've got a sufficient load path. There's other ways of doing that too, is you could swap out one of those ceiling joists for an LVL, and if it's sized correctly, then you don't have to have a rat run, and you could drop your purlin support straight onto that LVL. And those LVLs, again, Robert probably tell us they can't be over a certain angle. So you can't have a purlin that's at a extremely flat angle to a wall that's 20 foot away.
That wouldn't work.
It's got to be relatively close. So
I
that
imagine there's a degree that they probably run those at.
there is a minimum.
Nothing over 30 degrees or something.
Yeah. And I don't know
Yeah.
that number.
Right. Robert would know it. Also, something else is these ceiling joists. We're thinking of typical 2x6 ceiling joists, and we're kicking down. We're talking about the entire path, but you could run a whole series of ceiling joists as an I joist. And all of a sudden now you can use that as a purlin spot kind of anywhere,
You could.
and so you can beef up your ceiling joist and play the game that way.
You could. Absolutely.
As far as other supports, we're talking about supports and purlins. We need to support gable ends too. I mean, you don't see a ton of gable ends. Everybody seems to be building hips, but you have a big a gable end. It needs to have, don't have to call them purlins because they aren't technically purlins anymore, but
It's kind of almost a wall, almost.
you have to kick that wall down.
Mhm.
Same thing to a bearing point and follow the path all the way to the foundation because it's a giant sail. It's getting wind.
Yeah.
That's why you don't see a lot of gable walls here because of the wind, and the wind rolls right up the hips nicely. But you put a big gable wall in there and it's hitting the wind, it's going to be a really bad thing. So you have to put, sometimes depending how big the gable is, you'd put 2x6 verticals, maybe 6 feet off center, and then you'd kick it twice
Mhm.
to hold that gable wall from moving
Okay.
because it gets direct, wind load and it's like a sail on a boat.
Mm-hmm.
So you have to kick the gables as well.
Mhm. And when they start that gable, the first thing that they're doing is setting
Checking
that.
they're checking the weather for wind.
Well,
Then they're going home.
And they're
We're not
going
setting a
home.
gable today.
yeah, we can only set one 3 days out of the year.
You're gonna have to wait till like
Yeah, we only do gables in June. Sorry.
They set that ridge board, right?
Mm.
So, and it's the same on a hip as well. But when you bring that to the outside, they're basically making a pocketed beam the height of that ridge so that they can place that ridge board into it on one end, and that's holding that ridge board up so that they can drop their joists in. And then the other names about the joists, or rafters, sorry. The other name about the rafters we didn't talk about, you've got your commons, which when you have a whole string of them that are kind of cut the same. You've got your jack rafters, so your short ones. So if you are doing a hip or a gable roof, as it decreases down to that smaller triangle portion, each one, is smaller than the next. You have hips and valleys, ridges. So those are kind of some roof framing terms that we didn't really go over.
There's barge rafters.
Yes.
And so if you're going to have a rafter out on an overhang, there's outriggers and
Mhm.
barge rafters.
Mhm.
There's the fascia.
So the barge rafters and outriggers are going to be used for the soffit overhang on a gable.
Mhm.
Subfascias that's used around here a lot, which would be the size of your rafter placed on the end of your rafters before your decorative fascia on the outside of the house.
so a 2x6 going on to okay.
2x6 being nailed onto the ends of all those rafters, which one kind of helps those rafters from moving back to forth. Two, you can visually, you can take your line of sight and look down that and make sure that that's straight and tweak anything that you need to before any decking goes on, which can help you adjust the waviness of the end of the house. So, you can do it with a string line, or usually you just get it eye level with it, look down, and do your fine tuning on that. What else what are we missing on that now? We just went over a lot of terms.
So on the hip and the joints and all that,
Mm-hmm.
that little blue book that you guys were talking about,
Mhm.
these guys are just cutting and throwing. When you get on those non-common rafters,
Mhm.
I mean, I'm assuming all that's in that book, so they know if they're on this setting or this spacing. I just cut one, 60 inches. This one needs to be 55 inches.
Correct.
That's
Yep.
Yep.
It really is an absolute insane
Trigonometry.
Wow.
It's all
You just cut it and throw them, cut and throw, and
That's wild.
they fit.
and then a lot of those framers don't even think twice about it. It's just a pattern to them. They don't realize they're even doing trig, pretty advanced trig.
Right.
Mm-hmm.
It's a cool thing. It really is. And on those valleys, they're making like a double beveled cut on the end of them, so
Mhm.
that it's
It's a compound miter.
it's a compound miter on the end, so that it's basically meeting and connecting with both of the ridge boards
So it's being cut at an angle.
Mm-hmm.
twice at an angle.
And a lot of times you guys are just doing it with a worm drive
Yeah.
circular saw.
Sometimes they are.
That's,
Yeah.
that's wild. I could barely do it with my compound sliding miter saw. I guarantee.
Yeah.
I don't think a lot of guys use compound miter sliding.
No.
No, everybody just does it with a hand saw.
Yeah.
It's a saw.
Yeah, and then there's companies. This is worth getting into right before we get into talking about trusses. There are companies that you can send plans to, and they will cut your entire roof package
Mhm.
for you and ship it to you, and then all you gotta do is nail it. Everything's cut into place, ready to go. It's exactly like it should be, as long as in a perfect world
Yeah.
your
everything from
walls
the
are
top
exactly
plate is-
where they need to be.
Yep.
Now there's some modifications that can be made in the field, of course, if one of those is too short or too long. And so, but it's a pretty cool concept.
Yeah.
Off-site hand cut roof and ship it in and nail it all together.
And so when we were talking about the walls, if it's a box, we want that box to be square and nice, right?
Mhm.
But if the foundation's got a little bump in it, and that wall takes a little bit of a dive, that's right where a rafter sits.
Yep.
You're blown.
Mhm.
Because you figured that wall was going to be straight and planed, and now your rafter's sitting there and it's now a half inch low.
Mhm.
Not so good.
Well, that's what we were talking about with like the performance framing a couple episodes ago, and how the slab, everything starts And like we said on our first episode, everything starts with
Yep.
the foundation.
Right.
Yeah, I think everybody will start to realize as we go through this, because it is in every single detail that goes into the home has something to do with the foundation,
Hmm.
Mhm.
and the foundation is the key to success on it. It really is.
And if you made a mistake, it will eddy out somewhere.
It will.
You don't know where it's going to show up. It could be in the roof, and then you're like, oh man, we have to recut this section. Could be that you go to start, you lay your tile, and then you got run out when you get to that wall. You go, oh, that's where it showed up.
Mhm.
It will show up.
Yep.
You're not going to run away from it.
There's remedies and fixes for it, but
Yeah.
if you can start right,
Yeah, it's a big deal.
it'll
It'll make your day good. They'll go all the way through.
yeah.
Yep.
It makes it for a good day.
Concrete might be one of the things you don't want to go to the lowest bidder on.
Right.
So, well, Joe, let's hop into the whole truss system.
Truss system. What are trusses? So trusses are. We just talked about a company is going to hand cut you a roof.
Yep.
They're going to send it out to you in a kit. So in a truss, they're going to send you out the entire roof. Those triangles are all pre-made,
Mm-hmm.
and they're put together on imagine a big giant flat table, 30, 40 feet long, and they set up a jig and they start cutting rafters, and they start cutting ceiling joists, and they start cutting infill. There's always a pattern of infill based on engineering, and they have a big gang nail plate. They put it together and they make a one giant unit that is your roof, your ceiling, all in one.
Mhm.
And that's a truss. You can Google the word truss, and it will be really a pretty basic truss.
Describe the gang nail plate. I mean, I know everybody's probably seen one.
Well, if you're going to get close to one, you got to get a box of Band-Aids because you're going to get cut. They're short. It's a sharp chunk of steel, galvanized steel. No, it's not galvanized. It's bright steel, and there's a machine that as it pushes it through the wood, it just pushes all the little holes into nails, and it's just a gigantic, sharp as could be item that attaches the wood, because the wood isn't screwed, it's not nail, it's not toenail, it's just set in place where it needs to be on the jig. And then there's a big giant chunk of metal lays over the top and just slams a bunch of holes, bending the metal into the wood, and it's like a billion little nails in that little quadrant. It's called a gang nail plate.
So when you go to a restaurant that has a open roof system, where you can see the wood framing, if you look up next time when you're eating your dinner, you'll see that rectangular plate that's at every single joint, and that's what that gang nail is.
I was eating dinner somewhere not too long ago that had a truss roof like that, and they actually took the time. I'm trying to think of where it was at. Is they took all the trusses and they stained them, and they put them in, and then they did all the rest of the framing around it, and it looked pretty cool. But what a lot of work! To lay out a bunch of trusses out in the yard and spray a bunch of stain on them. But and they sprayed the gang nail plates and everything else.
So there's no adhesive on that gang nail plate.
Nope.
Man.
And if you've ever taken a bar and you wanted to take one apart, it's not coming apart. I mean, it's ripping the wood. It's just trashing that whole section. You can't get it off. I mean, I don't know exactly the machinery or the PSI, what have you, but they're assembled better than anything you're going to do in the field. Let's before we get too deep into the truss thing, we're kind of talking about how they're assembled. If somebody in the field makes a mistake and cuts a truss, that's all bad, because that is engineered to be that piece and that piece only. And so if you have to do a fix on a truss, there's a fix. You can engineer a fix, and they'll make you take 2 sheets of plywood, gussets on both sides, and add 400 nails to mimic the gang nail plate, and to make a new piece where something's been damaged.
So that would tie in like all the howls and all the other supports.
So that is a big difference. So a hand cut roof is not an engineered item. It meets required specs that are called out by code, but it's not requiring a engineered stamp to be installed. On the flip side of that, a truss system's engineered, and that it is pre-manufactured and meant to be installed in its entirety as a whole piece. And when you do a modification to it, you've basically voided that engineering so that it has to be an approved engineering repair again to keep that whole system engineered to meet code.
Right. I mean, they design wind load, snow load. They design everything into it, and so it's a pretty darn good feeling when you put that on a house.
Absolutely.
You know it's good.
Yeah, it wasn't something that the inspector may have missed that should have been there.
Or if it was a Friday afternoon and the blade was dull and they just threw something up there and toenailed it in.
Yeah.
So it isn't that much more expensive. Actually, it's less expensive.
Sometimes it's a lot less
Yeah, less expensive. So you can get a standard truss, like we were just talking about, a ceiling joist and the common rafters, and they'll sell the hip and the ridge kits and everything, and it all kind of puts together as a puzzle. But the one really kind of cool advantage to that is you can engineer in an attic into the truss. And in fact, I've done it twice here in this town, and they're called attic trusses. And so you basically get a free room because instead of all these purlins kind of kicking every which way, if you've been into an attic, you guys know you're kind of climbing in and out of sticks of wood. And if you're lucky, you didn't fall through the sheetrock because you kind of got tied up in one. But if you can imagine the triangle all engineered with the knee walls and the triangle in the middle, all part of the program, they'll give you, depending on your pitch, they'll give you a 6 or 7 foot ceiling height, 7, 6, or even 8 foot ceiling height. And as you're rolling these trusses, you're building an attic and you have an extra room.
Absolutely.
Kind of for free.
It's a rectangle portion inside the triangle. So if you, in simple terms, if you draw a triangle, go to the center of that bottom triangle and you can draw a square in there until you reach the 2 angled pieces. And that's kind of the shape of that truss.
Yeah. And they actually, the ceiling would be the normal ceiling joist are now a floor joist. So they double or beef those up. It's all part of their design, and it just shows up and boom, you got either storage or an attic space or really good mechanical room.
They also do almost the opposite of that, where you're not building in the attic space, but you're building a mechanical space above the sheetrock so that you can run ductwork on the lower level of the attic. So it's not in the attic, it's in conditioned space if you've got blow-in insulation, but it makes a mechanical, electrical
chase.
Duct
Just
chase.
running. Okay.
Yeah.
Which
it's
is
like a ceiling joist and a ceiling joist, and it's a cavity in there.
which are super handy, especially when you're doing insulation on the ceiling deck instead of the roof line.
Right. Anything you can imagine, they can build.
Yeah.
And they're good at it.
They are.
I did a truss system on this house out of town, and I had to design in cavities for disappearing blinds, electric blinds disappear in the ceiling. So I needed a truss that would go up over and still have a bearing point, and I just was drawing on it, and I sent in. And so I want engineer it. Boom. So you can't do that with a hand cut roof. You can't get guys out there with a skill saw and come up with those kinds of, like you're saying, the HVAC cavity chase or some crazy pockets for hidden blinds. So you kind of have to go into the truss world. It's a good world. It's a really cool place to be.
There's a sweet spot here for both of them. So a lot of times when we're doing like multifamily homes where the roof line doesn't change and time is of the essence and you're paying man hours, you can get a whole slew of roof trusses and knock that roof out quick. And it's the, most cost effective thing to do versus hand cutting that whole entire system. Some of our houses that are, say, around the 2,000 square foot range, refer to them as McMansions, and they've got a lot of jot outs on the walls, and there's not a box shape to it at all. It's just all over the place. A lot of times those hand cut are a little bit more affordable because it's not so customized in the truss system. But then you go past that, and then you get into a really complex house that does need certain ins and outs on mechanical spaces or hidden blinds or certain load points and paths. And you start getting back into the only way of doing that again is in the trusses. So there's kind of this, it's hard to always tell which direction to go to. And, commonly around here, it's hand cut because that's what our framers are used to.
Right.
But there's certainly times that one is significantly an improvement over the other.
So before we get into how to come up with a truss, there's other things that are neat about trusses. we're right now we're talking about roof structures
Mhm.
and a roof truss, and everybody's thinking of the triangle.
Mhm.
Okay, but let's say you have a modern house and you have a clear story and you have a shed roof, big shed roof to
Mhm.
one side. Those are trusses too.
They are.
So they're just actually they're a square piece of, they look like a regular nominal size piece of lumber, but instead of a 2x6 or 2x8, these are a 12 or 14-inch member
Mhm.
that are built just as a straight piece. They have a plumb cut on them, and you can stick them up into a beam, and you can run a shed roof out the side, spanning a 20-foot room, and they're an open web truss.
It's
Okay.
it's
So-
about the only way to really do that. It's like a floor truss at an angle.
That's the next
on
thing
a
I
roof-
was going
on
to
a
say
roof.
is an open web floor truss.
Yeah,
It's a truss.
it is.
And so we're way past our floor system. We might have talked about
We did.
open web trusses, but trusses as a whole, don't think of them just as a triangle roof thing.
No,
There's a lot more to them than just a triangle box on your shed.
absolutely.
As far as how to accomplish trusses, you have to start from the beginning on them with your
Mhm.
plan. You have to know that you're going to do trusses, and right from the very beginning, your designer and or architect needs to be thinking trusses.
Mhm.
It's a little difficult to take a plan on the fly and turn it in. It's not impossible, but to turn it into a truss designer and get it transferred over.
Mhm.
Part of it is the truss companies don't want to spend the time and money on their engineers giving you free engineering without you committing to trusses, and it turns out you didn't buy them.
Mhm.
And they have engineers that did dumped 20 hours into your plan, and you decide, nah, I don't want to do them. So
You're right.
that's kind of a thing. So it's a commitment. Either you're in or you're out from the beginning, and go with it from the beginning, and don't try to convert something that I wonder if this would work. It gets clunky then.
So back to there's times to use a hand cut versus a truss system. You've got to have faith in the knowledge and understanding between your designer, your architect, your draftsman, and your builder to know that they're going to spec the right thing at the right time, because you're not going to draw a house for a truss system and then halfway through it decide that you're not going to do a truss and then go back and do a hand cut, or vice versa. You really are going to pick a path,
Make your commitment.
make a commitment, and
Yeah.
head in that direction. By the time you've priced one system out and then corrected the drawings and priced another system out, you've just
You're
wasted
6 months later.
and you've just wasted the money that you would have potentially saved going from one to
Right.
the other.
Right.
Um,
So you're right. There's a need for both,
there is
for sure. I mean, I in my heart and soul, I kind of like trusses a little better because I know that someone stamped it, and it's not a guy out in the field with a blue book.
right.
I've been that guy with the blue book, so I get it.
Sure.
But these are made and engineered. The snow load's figured, the wind load, everything's figured out for you. And when that's up there in your house, you're like, yeah, that's pretty good.
Yeah.
So as far as installation goes, do they have a pocket for a ridge?
No,
There's not a ridge. They're just going to set straight on top of your walls.
So what keeps them from twisting and flipping? And I mean, I guess you have to space out. You're going to space it out at
So
16, 20.
So there's a few ways of doing this, but before I get to the ways that I know of doing this, Joel, how was your typical installation? And you fly one up there. How did you hold that one in place? And then when you flew the next one up, how did you attach it?
the blocks at the top?
Yeah, just 2x4
Yeah,
scrap pieces, basically.
Yeah, they're all cut, 22 and a half,
To
whatever
space
number.
them.
Yeah, then it's just a space and go. So you don't have to have a tape measure up there when you're rolling trusses.
Yeah.
You just bam, bam with a block, slap the next one over, bam, 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 bam.
So you're just
And
piecemealing
and as
a
you're
ridge.
going,
Yeah.
you'll get 2 or 3 stood. You can check your level, make sure you're not running the whole thing out one way or the other. And then the sheeting, and that's
Holds
it. But it doesn't need a ridge because it's got its own personal triangle,
Right.
all individually designed. It's not going anywhere. No purlins needed because and you can engineer spaces into these trusses for ductwork. If you say, hey, I don't want just your typical little Y or X or something. I'm going to run something through there so you can get it with them up front. I want a 22 by 21 inch hole running from end to end because I'm going to put something in there. I'm going to put a duct in there. I'm going to put something in there. You can ask for that.
So you can
know.
also, I imagine, do aces or vault in
Sure.
these as well.
Absolutely.
all the time.
Absolutely. And so the installation of those, what's going to happen is your framer's going to go on those top plates and they're going to do a layout on both sides and mark that layout. This is where this truss is landing on the end, on both sides of the wall, all the way through the wall. They're going to fly that up there. It's going to go and it's going to land exactly where they marked it. And then when they start the next one, that's that, 24-inch piece of board, whatever that layout's going to be. And that sets the top spacing in line with your bottom marking. And then your spacing continues on. That's
So here's the bad news. Want the bad news?
Absolutely.
Okay, so in a community where trusses are the main thing and there's many truss yards, what you do is you pour your foundation, okay, and then the truss company comes out and measures the
they
foundation.
approve you.
And, what's that?
They approve your work basically.
Well, they basically approve your work and then they build to your foundation.
Mhm.
So by the time your walls are built, those trusses are done and they're delivered on top of with a crane truck. They deliver them and they put them on top. Okay, that doesn't happen here.
Mhm.
So if your foundation isn't right, your trusses aren't going to fit.
Mhm.
And so you have to pay big time attention to that everything is exactly per plan. And if it's off an inch or two over here, by the time they build those walls and everything's plumbed up and those trusses come, guess what? They aren't going to fit.
Yep.
You're going to slide. Hey, I need to slide it my way. I can't slide it your way. No, you slide it my way. I can't
Mhm.
because they're too short now because your foundation was goofed.
Yep.
So that's the bad news. You have to really, really, really pay attention when you start.
And people listening that haven't done a layout for a slab on grade, they're probably thinking, well, why are the concrete guys missing this stuff? I mean, it could be as simple as they snapped on the wrong side of the board and they're 1.5 inches off on one corner
Yeah.
to the other. And so there's 1.5 inches taper throughout that whole length of 25 foot. Well, that causes a problem with trusses because now your eave, your overhang, is going to have an 1.5 inch difference on one side to the other, all because somebody measured to the wrong side of the board.
Yeah.
And you've got, 40 boards laying on the ground. What if it happens a couple times? It's one of those things that it can happen very easily, and it takes a while to discern or find out that the layout isn't correct
Mhm.
because there's so many dimensions that can be pulled and need to be checked that we usually spend, literal hours on site
Oh, for sure.
on the forms just to make sure that
Right.
they're never going to intentionally miss one. It's just it's a handcrafted thing and hand measured and placed by
A lot
hand.
of people with a lot of tape measures pulling
Yeah.
in a lot of different directions.
Absolutely.
And so if they do miss it, then you basically get together with your framer and you might have to hang a wall out.
Mhm.
Mhm.
Because no matter what, if your wall has to be square and plumb, or
And look good.
and look good. So if you have to hang a wall out, well, then you have to get your foundation guy back to do a little mudding and making sure it's all kind of looks the way it should look.
Mhm.
So that's the bad news about trusses. You got to pay attention. It isn't for the faint of heart. Builder driving by,
Chuck in the truck.
yeah. what do they call it?
Chuck in the truck.
Yeah, it's not for that. You got to get out of the truck.
Yeah.
And pay attention if you're going to do trusses. But there's so many benefits, and it's such a cool thing. And in this area, I guess this is a national podcast, so who knows what the whole world thinks. But in our little Amarillo world, our Builder's First Source lumberyard bought the truss company that was local here for. They had three or four truss yards. So our lumberyard is serious about trusses. I mean, that's the message. I was dealing originally when I first got here with the truss manufacturer themselves, and they had a sales guy. And I would talk to the truss. I talked to the lumberyard. Hey, do you guys do trusses? Oh, we don't know about trusses. No, I don't know anything about trusses. And next thing you know, they bought the company, and now they're all learning about trusses. The sales guys they're taking training. There's a main head guy in Lubbock now, and so just know the trusses are on their way here. Builders First Source wouldn't buy 3 truss yards in our area if they didn't believe in trusses.
Yeah.
Joel has changed the game for.
Oh yeah, I did it personally. I showed up and now
He said, "I want trusses."
I want truss. I want you to buy 3 truss plants for me.
Mhm.
My little.
Well, that's
Yeah.
cool.
But,
We needed it. you
Yeah.
know?
So embrace it because it's here,
Yeah.
enjoy it because it's here, and see all the fun things that you can do with it.
So now all the listeners, whether they're homeowners or builders or somebody thinking about building a home, now has an idea of, do I want a hand cut? Do I want a truss? What do I want to specify to my builder?
Mhm.
And maybe some of the potentials, benefits for either one. So it's definitely a discussion to have. I don't think it has to be always one way or the
No, I
other.
don't think it does either.
Um,
I mean, I'll be honest, which I am, a pretty honest guy. This one we're doing right now, I was heading towards trusses,
mhm.
and I want some specific things within this truss for HVAC and platforms, and I being that this our truss company is really new now, and they're
Sure.
transitioning. I ran out of time,
Mhm.
and I hand cut it.
Yeah.
So I'm not drawing the line in the sand. I do what I need to do, and it turned out beautiful.
You did.
It's a very nice hand cut, but sometimes the engineering, I guess that lesson back to what I just said at the beginning, start at the beginning, get your designer to do that. And if your designer is not familiar with it, then get your design plans to a truss company right away.
Sure.
And get all that taken care of,
Sure.
so.
Well, I think we've kind of wrapped up on the roof framing.
We didn't really talk about dormers.
Yeah, we didn't talk about the style of roofs. There's a lot of styles, and we might get into that when it might be a whole episode on its own when we talk about, Tudors and Craftsman's and
Sure, right. Shed roof and gable dormers and flat roofs.
Yeah.
We didn't really talk about the flat roof framing.
We didn't.
But we're out of time.
We are out of time. I
Yeah.
don't know if we'll do a part 2.
We gotta
on
go.
roof
We
framing.
gotta go. Yeah.
But we're glad to be back in the saddle on the podcast, and
With a sponsor.
we're
Huber.
super
Huber.
thrilled to have Huber
That's
as
cool.
a sponsor. And like I said, proud to have them because it's one we believe in as a company that's been around for a long time, and their support's awesome, and their technical expertise is
Mhm.
easy to get a hold of and works really well. So it's nice to have a sponsor we believe in, and we'll be moving on to some of the products that they sell when we're talking about
Okay.
roof decking and sheathing, which was kind of the next jump before
For what? Before the next jump after that.
the next jump after that. Yeah,
Yeah.
it's the next thing on the home building process. So stay tuned for the next episode. We're glad to have you back, and we'll see you soon.
See you in a few
See
weeks.
ya.